We've got some operations for matrices. We're allowed to add them, and we're allowed to multiply by a scalar, kind of like when we talked about vectors.
And we can subtract.
Technically, when we subtract, we're adding something that we multiplied by a negative. So yes, we can subtract, but really we're adding the negative.
So we're subtracting.
Kind of.
Well, to get to what Mrs. Stevenson is saying, all subtraction is adding the negative number.
Right.
So
we want to take these matrices and do A plus B. Matrix addition is super easy. You take the elements that go together and you add them together. So like first row, first column, plus first row, first column. So that
and this is where the highlight issue can come into play.
Yeah, you could potentially like highlight this a color, this a color, this a color, this a color, and then do the same thing over here so you can tell the difference.
Right.
So 2 plus 1 is 3. You can go either direction. Now from here, I'll go down. -1 plus -2 is -3.
And notice that the things that she adds stays in the same place.
Right.
So row 1,
move.
column 1, plus row 1, column 1 goes in.
Row 1, column 1. 3 plus a -3 is 0. 5 plus a -4 is 1.
Boom.
That's A plus B.
Blamity blim blam. Dunskies.
So how about A minus B?
You're going to do the exact same thing, except now you're going to have negatives.
So I'm going to write
addition part
out what we're doing here. 2, -1, 3, 5. And we're subtracting. So I'm going to add instead, and I'm going to go ahead and change these all to negative of what they were.
Right.
So -1, +2, +3, +4. So by putting the negative inside, I would change this to addition. And now I can easily figure out what those are. 2 plus a -1 is 1. -1 plus 2 is 1. 3 plus 3 is 6. 5 plus 4 is 9.
There you go. So it became an addition problem, even though, that's what I was giving Mrs. Stevenson a hard time about just a minute ago.
3A.
3A just simply, easy for you to say, simply means multiply each element inside the matrix by a scalar of 3.
Right. It's like a more complicated distributive property thing. We're distributing the 3 into everything that's inside of here.
Everything.
So 3 times 2 is 6. 3 times -1 is -3. 3 times 3 is 9. 3 times 5 is 15.
There you go.
And last, 2A minus 3B.
So now you're going to multiply by the scalars first on both matrices, and then whatever you get, you're going to add.
Right.
And remember, we're going to take care of that negative sign by multiplying by -3. So we're good to go.
So 2 times the matrix A, so that'll give us 2 times 2 is 4, 2 times -1 is -2, 2 times 3 is 6, 2 times 5 is 10. Plus, now I'm going to distribute the -3 into the second set of parentheses. So that's -3, +6, +9, +12. You watching to make sure I'm doing it right?
I started to daydream. Sorry, I have a soccer match later, and but I'm going to go with yes. It looks -3, +9, -6. Thanks for calling me out in front of everybody.
You're welcome. Okay, now let's add these together. It's not what my intention was. You really looked like you were actually hardcore paying attention.
Sorry, there's a soccer match later.
Excuses. Yeah. Hey, did you guys win last night?
We did. Yeah, it's pretty good. Yeah, Laramie Hall went nuts again. It was great.
Good.
Yeah, and she just got on the internet.
Yay! Awesome. All right, that's how you do matrix addition and scalar multiplication.
Don't let this be hard. This is not a hard thing.
Now, here, let's throw this out there. You can multiply any matrix by a number. That's fine.
Right.
But you can only add or subtract them if they have the exact same shape.
Right.
So all of these, well, they were the same matrix the whole time. These were both 2x2 matrices.
So they have to go with 2x2 matrices.
Yeah, if you had like a 2x2 and a 2x3, you'd have to say, no, sorry, I can't do that.
Right.
And
Like it's not possible.
Sense. There's not enough things to add together.
Right.